Hi, and welcome to the third episode of Azure Database for MySQL Troubleshooting Series. My name is Sai Kondapalli, and I'm a product manager for Azure Database for MySQL. In the last two episodes, we have provided an overview on troubleshooting and the methodology that goes with it. And we have also covered a session on connectivity issues, the error messages that you would encounter with connectivity issues, and how to get around them. Today, in this episode, I'll be talking about troubleshooting high CPU utilization issues in MySQL, the various tools, MySQL diagnostics that you can leverage to identify, spot an issue, and resolve the issue. Today, in this episode, I'm going to give a quick overview on CPU utilization and what some common symptoms would look like when there are CPU spikes. And we'll also talk about the causes that are leading to these CPU utilization spikes. Later on, we'll move in and look at identifying resource bottlenecks in Azure Database for MySQL Flexible Server, the common tools, the features, and the integrations that are developed into the product. Later on, we'll discuss about best practices that you have to leverage for your database server so that you do not frequently run into CPU utilization spike issues. And finally, we'll be doing a demo where we'll also show how to capture current workload details that would help you to identify and spot an issue with CPU spikes and how to resolve them. So, what are some of the common symptoms that you may encounter when there is a high CPU utilization on your MySQL server? Things such as, a single query that is running slow or a set of queries that are running slow. And when this happens, you may be observing timeouts happening on the application side. And when timeouts are encountered, you may observe that your application is actually releasing a surge of connections to the database server, which in turn can cause and hamper the database application side performance. So, what causes this high CPU utilization in the first place? First and foremost, resource bottlenecks. Things such as inadequately sized database server that could lead to these CPU utilization issues. And in cases a customer has initiated a long running transaction, that could lead to an eventual slowdown of the application and the database servers. And a leading factor could be a poorly written query where indexes are not properly leveraged, and there are chances to identify indexes on the tables and provide them to the queries so that these queries would actually reduce the CPU utilization. And other factors such as your statistics for the tables are out of date, which means that the query cannot take the proper execution plan to retrieve a record or set of records, which can also contribute to higher CPU utilization. And similarly, missing indexes on the table. If the indexes are not properly leveraged, then obviously the MySQL optimizer has to do a full table scan, in which cases you may see that there is a very high chance of CPU utilization spikes on your database server. And finally, parallelism issues, which could lead to things such as blocking, deadlocks, etc. And being a PaaS managed service, Microsoft provides monitoring tools to gauge the performance and health of your database server. You can leverage these monitoring resources to understand resource utilization, analyze the application workload that is coming to the database server, understand and identify if there are any failures that are happening, and decide when to scale your resources or scale down your resources. And also, you can set alerts on top of that. When troubleshooting for high CPU issues in MySQL through metrics, looking at other concern metrics besides CPU is very critical to understand the nature of the issue. Azure Database for MySQL provides metrics related to different resource dimensions that can aid in spotting an issue and resolving the issue. For example, when CPU shoots up, you should always consider looking at metrics such as memory, IO, and others to fully understand the nature of the issue. Azure Database for MySQL provides these critical metrics in the overview page of the database server. Furthermore, you can get additional details in the metrics blade of the database server in the portal and provides you with detailed information such as traffic related information, where you can gauge the connections, the network in, out, etc. And you can also look at the resource saturation such as CPU, memory, storage, IOPS, throughput, etc. And any errors that could be like the active connections, failed connections, etc. And finally, you can leverage workbooks to canvas metrics and attain additional query performance insights. So, what are the best practices to prevent from getting into such situations? First and foremost, it is very essential that you monitor the crucial metrics for your database server. Besides keeping an eye on the metrics, it is also very vital that you have a baseline information on what the utilization numbers for each of these metrics should look like in an ideal scenario. So that way you can quickly go back and correlate whether the spikes are abnormal or not. And to be more proactive, you can set alerts on these metrics so that you get notified when there is a CPU spike, or when there is a drop in memory, or when there is a surge in connections coming from the application server, etc. Besides that, another proactive measure that you can take on your MySQL flexible server is enabling the slow query logs. When you enable slow query logs, it essentially provides you with critical query related information where you can quickly dig in and diagnose whether the query is behaving abnormally or not, whether the query is exceeding a threshold that you have defined for that. In addition to that, all the tables that are in your database server should have the statistics up to date. If the statistics are not up to date, it would mean that the MySQL optimizer is not able to pick the right execution plan, which would entail a higher CPU utilization on your database server. Frequently run diagnostics on the database server, such as understanding if there are any mutex issues happening inside the MySQL database engine. Are there any blocking happening, any deadlocks that are happening on the database server? And if your application workload is in such a way where there is a large read activity happening besides the writes coming in from the application server, do break down the application workload into primary server and read replicas, where the read workload is heavily leveraged by the read replicas. That provides you with read scalability, as well as it brings down the heavier utilization on the primary server that is backed for your application server. Finally, if your application has large number of tables that are larger in size, more than 1 TB in size, etc., do partition these tables, which would provide optimal query response times as well as quicker retrieval of record sets from the storage. Now we are going to look into the demo on monitoring and troubleshooting high CPU utilization in Azure Database for MySQL Flexible Server. I'm currently on the landing page of my Azure Database for MySQL Flexible Server. And in the overview page itself, as I scroll down here, you can see there are a bunch of tabs that are available here, where getting started properties, recommendations, monitoring, etc. And if I go to my monitoring and I scroll down, I can see that there is some sort of activity happening on this database server. As you can see, there is a spike in IO percentage, as well as there is very high utilization of the entire memory bandwidth on this database server. And similarly, we can see that the CPU is surging now from 3 or 4% previously to above 50% now. And also, as you can see, there are like bunch of queries coming into the database server, and the DB connections have also spiked up, which would mean that this is a user-initiated workload happening on the database server, and that is actually leading to higher resource utilization over here. Let's go to the monitoring blade, and we'll quickly dive into the metrics to see these details in depth. So I'll go to the host CPU percentage here, and it looks like in the last 24 hours, there is another spike where it has almost touched 100% on this particular database server. Let me now narrow it down to the last 30 minutes and see if the CPU utilization can be observed here. Yes, I can see that the CPU has spiked to more than 50%. Previously, I did mention that there are other metrics that you have to always take into consideration when diagnosing high CPU issues, such as memory. As you can see, this database server is running pretty hot, where most of the memory has been consumed on this particular machine, right? And in addition to this, let us also look at some storage side metrics as well, specifically on the IO, because if there is any IO saturation, it could also mean that there would be higher CPU utilization on the database server. The primary reason for that is basically most of the transactions that are coming in from the application are waiting to either retrieve the records from the storage or waiting to write to the storage. And that is how storage saturation manifests as. Besides this, there are like tons of other metrics that you can leverage. I'll quickly walk through some of the important ones. Like if there is a surge in database connections and if they are being rejected by the database server, since most of the memory is consumed as well as CPU clock cycles are not available, you can see a spike in aborted connections. Similarly, you can also look at some InnoDB related metrics such as the buffer pool related statistics, such as if the database is getting polluted with a lot of new requests coming into the database, which means that the CPU is going to run hot as well as the memory is going to run slow here. And besides that, you can also quickly gauge the traffic. And similarly, you can look at some of the other DML and DDL related metrics that are available here in the metrics section, such as you can check the number of selects happening. As you can see, there are about 236.79 thousand selects that have happened on this particular database server. And this is the sum of the selects happening over a period of time. You can even narrow down and check what the select count does look like in that particular period. And in the best practices section, I did also give a brief overview on setting server parameters and specifically slow query logs. Go to the server parameters blade, look for slow query log. And if it is off, do turn it to on. That means that your slow query logs are now being generated. And to ensure that slow query logs are working appropriately based on a threshold, you have to also set another parameter, long query time. And in my case, I have set this value to 10 seconds. So which means that any transaction that is taking longer than 10 seconds would be logged in the slow query log. The other advantages and integrations that are available with MySQL Flexible Server or with things such as the storage accounts, etc. What you can do is you can pump in the metrics, the slow query logs, as well as the MySQL audit logs to another storage destination. This is done through diagnostic settings. And the way you do that is you quickly go to add diagnostic setting, you provide a name over there. If you want to include all the logs, you would say all logs, and that includes both MySQL slow logs and MySQL audit logs. And you can also pipe the metrics to a destination of your choice. For this demonstration, I have actually created a diagnostic setting where I am pumping all of the MySQL logs to another log analytics workspace where I can perform queries to identify if there are any slow queries. Let me quickly show you how to query that and fetch the result set. For example, let me run this query to identify slow queries that are running on this particular database server. As you can see, I'm getting like a bunch of this information. Let me click on one of this now. This particular query, select counter star from this particular SB test 9 table, has taken about 48.512 seconds. It gives in more information such as the number of rows that have been analyzed and sent back, etc., whether there has been any locking, etc., happening, and also to quickly gather details such as the start time on this particular query. Similarly, let's also run another query to quickly gather information on the average duration for queries that are running on this particular database server. As you can see, I'm doing the same transaction of the query from the previous tab, select counter star from SB test 9. And so far there has been just one occurrence of this query. And the minimum query time has been 48.512 seconds. So which would mean that the min max average queries are relatively the same. But if you have run this query for like hundreds and thousands of times, then you would start observing what the average query time should be and if there is any deviation in the query performance. Now let's go in and look into server logs and take a look at the slow query logs that are available here. I have already enabled server logs for my database server, and the logs that I have enabled today are slow query log. And I'm going to look at today's slow query log for the database server, and I'm going to click on download. As you can see, all of the slow query logs that we have observed in the previous query have also been logged into the actual MySQL slow log, where you can quickly get each and every single query when they have run and how long they have been running, etc. here. Let us also quickly walk through the workbooks. There are 4 preloaded workbooks that are available in Flexible Server. One is the overview workbook, where you get quick summary of your database server. And similarly, you also get details of all the MySQL databases or schemas currently on this database server. And you can quickly canvas and look at information pretty closely using workbooks, where you can summarize multiple metrics as well as multiple queries together. Over here, we can see connection metrics, the queries metric that is populated here, and other relevant metrics such as your CPU percentages, the memory percentages, IO percentages, etc. And finally, the storage utilizations and the backup storage utilization as well as storage percent. Let's go back and looking at other queries. Auditing. If you have auditing enabled, then you would be seeing relevant auditing information here for any DML or DDL queries running on the database server, as well as select statements or any other relevant activity happening there. And finally, we can also look into query performance insight, where you can look at the query load and total active connections, and similarly what the slow query trend is looking like. How many queries are being logged on an hourly basis that are greater than the long query time, which is 10 seconds that we have previously set in the server parameters, right? And then going in, we can also look at the slow query details, which we have also gathered through the analytics workspace queries that we have run a few moments earlier. So it makes it easy for you to quickly gather all of the information at once and start troubleshooting easily. And in a very highly concurrent database environment, there may be multiple hundreds and thousands of queries that are running on an hourly basis. And in those cases, it becomes really difficult for you to identify which are the longest queries. You can quickly come to query performance inside workbooks in Flexible Server, and you can look at the top 5 longest queries that are running on this database server. As well as you can also look at the standard deviations of the queries based on their min execution time, max execution time, and other relevant parameters. And finally, you can also leverage enhanced metrics, where you can look at things beside the metrics. You can look at the buffer pool utilization of the MySQL InnoDB storage engine, how the InnoDB reads and writes are progressing, as well as some other MySQL status counters such as your insert statements, delete statements, and DDL statements such as creation of databases, drop of databases. Now let's move in and look at running some queries through the MySQL Diagnostics. I have currently logged into a Bastion virtual machine through which I'll be able to connect to my database server. And we have just seen that there is some high CPU utilization that is currently happening on the database server. So let us go in and look at the process list on this particular database server. As you can see, there are like a bunch of queries that are running for some time. So this particular query is in updating state. So it is performing an update on this particular table, SB test 8, etc. So similar to that, there are other queries that are currently running on this database server. And this is just providing a very high level information. Let us also look at the InnoDB side of things and how that manifests. So I'm going to run show engine InnoDB status to see if there are any mutexes and other activities that are currently running. We'll start from the top here. So this particular InnoDB status information is actually calculated for the last 43 seconds, and all the averages that we see in this section are for the last 43 seconds. If you want to have a detailed historical analysis through engine InnoDB status, then you would have to run this particular query on a periodical basis every minute or every couple of minutes, so that you have detailed information and analyze if there are any mutexes, if there are any semaphores that are happening. In my current workload that is running in the background, as you can see in the semaphores, there are a bunch of buffer pool reads and writes happening over here. And when we come to the transaction section, one important thing to note is the history list length. It is very vital, because the larger the history list length is, the greater the CV utilization would be, because transactions cannot get a consistent snapshot and they would have to iterate through all the old record snapshots when constructing a particular query's read state prior to the commit. Any history list length value greater than 100,000, like the one that we are observing now, or in millions is very harmful, and that can slow down not just one query, but the entire application queries hitting your database server. And in this particular section, besides the history list length, we can also gather other details such as the transactions that are running now. And you can see the state that they're currently in. Some key information can be noted down here. For example, for this particular transaction 335462, we can see that MySQL table in use is 1, and it has logged a certain rows or range of rows to perform updates, etc. And it's also providing other useful information such as transaction can only read or perform consistent snapshot view based on these particular IDs, which means that if it has to go further back, it would have to iterate through a lot of clock cycles, which is again the history list length, and that would translate to higher CPU utilization. And having tens and hundreds of these queries would mean that your database server is definitely going to run hot, and there would be high CPU utilization there. The file IO section kind of provides details as to what the IO threads, the read IO threads, as well as the write IO threads in MySQL are currently doing. And one thing to look at are the pending flushes. So right now I don't have any flushes because it looks like more or less those flushes, fsinks have already been taken care of in the background. The other important thing to consider is the buffer pool cache hit rate. In my case, it says the buffer pool cache hit rate overall is 980 out of 1000, which means it's at 98%. In larger database environments, this is not a good value. You would always like to have the buffer pool cache hit rate more than 99.5%, which means not all of the queries are hitting the storage system, but they are actually served from the buffer pool or the memory, which means they are optimal, they're efficient, and they are quicker for your application at the end of the day. And since buffer pool is segmented into multiple components, depending on the database memory size, you would get individual buffer pool information. In our case, it could be 8 partitions. So up buffer pool 0 to buffer pool 7. And you can also individually look at the buffer pool cache hit rates for each of these buffer pool instances that we are looking at now. And finally, the other important information when you are analyzing for CPU utilization is to understand the nature of transactions. And for that, in the show engine InnoDB status, the critical section would be row operations. And in this, you get the averages for the last 43 seconds. There were about 944, 945 inserts per second happening on this database server based on the InnoDB analysis, and about 1,884 updates per second, but the reads are pretty heavy, which means this is a read heavy transaction. So let us look in further and see what the processes are doing with a query that can provide more detailed information, such as the transaction ages, etc. There are a bunch of rows that we have retrieved over here. And let us also look at some other details, like, if there are any open transactions that are running in this database server now. So there are 16 open transactions that are currently running on this particular MySQL flexible server. And you can gather more details based on the transaction age, what state that they currently are in, if there are any logs, and what the isolation level is, etc. Right? So all of that information is also provided through this query. So most of the transactions that we are seeing here are pretty quick, but more and more of these transactions are being spawned by the background job that is running. And once you identify a query from these MySQL diagnostics, then you can always run an explain command on that. So for example, let me take this particular query. So as I run this query, it says that the execution plan select type is very simple, and it's currently running on this table. There are no partitions for the table. The keys that this particular optimizer is expecting on this query is a primary key, and it is currently leveraging primary key, which is good. That means the query is running optimally. If you see the possible keys as different and the key that the query is leveraging is different, then it means that there is an opportunity for you to fine tune the query further. So that way, It does not perform table scans, but rather leverages the indexes to retrieve the record, and that would mean lesser CPU clock cycles and lower utilization of the CPU on your database server. And we can also perform deeper analysis of each and every single individual query by profiling in MySQL. In my case, I'm going to set profiling to on. Let me execute the same select query and see what path it is taking. I just executed this query. I'll do show profiles. The query ID for this particular transaction is 1. So I'll do show profile for query with query ID as 1. And that should give me the information on where this transaction is spending most of its time. If this transaction has been run multiple times, you would be seeing values similar to this. But if you are running any transaction for the very first time, you may be seeing things such as, it is in a preparing state, executing state, or more or less in sending data most of the time, which means that the data has been retrieved from the storage, and it is preparing the data to be sent back to the client machine from where the request has initiated. So network packets will be sent back, and that is when you'll be seeing a lot of the large queries in MySQL database servers spending most of their time in sending data state. Once you identify any queries and you would want to get immediate remediation for those queries, you can always run a kill command. Please be very careful when you're running kill command so that you are aware of the consequences when you're killing a transaction. Once you're fully aware of the consequences, then and only then please run a kill command on the queries that you are identifying. And that concludes my demo today. Our resource page gives you access to various contents. Please do bookmark it and reach out to us on email for questions, feedback, etc. And follow us on social media for updates on new features, improvements, as well as learning content. Thank you for taking the time and tuning into today's episode. Please do stay tuned for more episodes on Troubleshooting Series. Have a good rest of the day.